Okay, so I started recording as well. Hopefully this time we are recording. So I believe yesterday we did good number of programs, and we tried understanding what exactly. Excuse me. Um, so yesterday we did good number of programs in assignment that we gave, right? Like the assignments. So today we're going to talk about object-oriented concepts. What is object-oriented programming and how it relates to Java. So we kind of understand one great thing about Java as of today is it comes with um, Java. It's independent of the platform. JVM is dependent on the platform. Java is dependent on the JVM, but Java is independent of the platform, right? So that is one main reason why a lot of industry choose. And second thing is it's mainly focused on supporting web-based applications. And the third one is it it adapted object-oriented programming concepts. That is nothing but OOPS, object-oriented programming concepts. Okay, so in object-oriented programming concepts, uh, basically we have what you called we need to understand what is object, we need to understand what is class, and we need to understand the four main concepts like abstraction, encapsulation. We have document, right? Let me open it so that you can look at it while I'm talking. Did I open it already? Yeah, it's already open. So there are basically operating object oriented programming is the what you call the specification. It's just a concept. There is no implementation. I mean, anybody can implement. They just say like, okay, the world should be like this. Okay, when you define when you define an object, the object should have these things. The object should carry properties. The object should carry the behavior. Then you can call that as an object. Any in the world, you can look everything as an object. So these are all just like a typical plain concept based specification is there. So if Java want to adapt it, Java can adapt it. If some other new language like Scala or some other language want to adapt it, they can adopt it, right? So Java also decided to adapt this object-oriented concepts as part of Java language. When they are developing Java language, they adopted the concepts, object-oriented programming concepts. So four important concepts is abstraction, encapsulation, and what you call inheritance, polymorphism. So these are the four. There are bunch of object-oriented concepts has been there, but among those, Java adapted these four important: abstraction, encapsulation, inheritance, polymorphism. These are the four concepts that Java adopted among the bunch of concepts, object-oriented concepts that has been there. Okay, so a plain definitions of abstraction, right? Abstraction is nothing but providing necessary properties and what you call operations of an object by hiding the internal details is called abstraction. So if you take before we talk about these four concepts, let's talk about object, okay, so that we guys get into easily. Oh man, this is irritating. Give me a second, let me drink water. So before we talk about these four, let's talk about an object, right? So when object-oriented programming, what is an object, right? So as per object-oriented concept, anything you call it, anything you see it, anything you feel it, anything you hear it, right? Anything in the world is an object. As simple as that. You as an object, the computer that you're sitting in front of is an object, okay? The table that you're sitting, that is there in front of you is an object. The chair, the car, okay? Anything, the dog, anything in the world you can consider as an object. So when you call an object, it has two things. One is properties, another one is behavior. One is properties, another one is behavior. Okay, so properties are nothing but, you can call it as an attributes. A behavior is nothing but operations. So if let's take, like I mentioned there, let's take a simple car, right? So like I said, anything in an object, car also falls into an object. So the gears that the car is having, the brakes that the car is having, the tires that the car is having, the seats that the car is having, all these are properties. All these are properties that has been given to this object called car. Then when you changing the gear, that is an operation, right? So by changing the gear, you are bringing some some behavior into the car, right? Some, moving is the behavior that you are bringing by changing the gears. So changing the gear or else applying the brake is nothing but an operations. Okay, so I hope you guys are getting my point. So when you see a car as an object, anything that has been fitted into that car is a properties, and whatever the operations that you can do through them are nothing but attribute, behavior or properties, right? So pen, or else, like, if you take a dog, right? What is the dog properties? Like legs, eyes. But what is the behavior? It can bark, it can identify thief, kind of thing. Make sense? So that is how the object has been defined in the object-oriented concepts. Now let's talk about abstraction. So like I mentioned, right, there are four concepts: abstraction, encapsulation, inheritance, polymorphism. These are the four concepts that Java has been adapted from object-oriented concepts. So let's simply understand these four concepts, and then let's see how Java adapted in the programming language. Okay, so first thing is abstraction. It's just providing properties and operations of an object by hiding the internal details is called as abstraction. So let's take a car again. In the car, you see the brakes, gears, seats, all the properties, right? Tires. But they act based on the operations, right? You don't need to you don't need to go and see what exactly has been kept inside while defining these properties. Like when they're defining type tire, you don't need to worry about it. All you need to worry about is the operation that you do, right? The operation that you do when you change the gear, the tires will rotate. When you apply the brake, the tires will stop rotating, right? So through operations, you are playing with the properties. Through operations, you are playing with the properties, right? So that is, if so for outside world, in the sense, for me, like as a human, for me, car looks like an object, and the operations are controlling the properties without giving the internal details. Like, in simple way, when you apply the brake, tire will stop, right? The tires will stop rotating. How come it happened? You don't need to worry about it. Outside world should not worry about it, right? You getting my point? Try to see, like when you apply the brake, that tires stop rotating. Why? Because internally the behavior has been connected between these two properties. Is when you press the brake, it internally goes all the way and apply, controls tires rotation with the arms, right? That is what called, whatever the internal things that has been set it up, you don't need to worry about. Outside world should not worry about that an object's behavior, right? All outside world is okay. When I apply my brake, I'm going to stop my car. When I apply my accelerator, my car will go forward. When I change my gears from 1 to 4, the car speed will increase. So this is the definitions, this is the behavior that has been given. So you don't need to worry about how the speed of the car has been going to change, right? So that is what called an abstraction. Okay. And then encapsulation. Encapsulation is, in simple words, writing properties and operations that are going to operate on properties. The operations that are going to operate on a properties in a single entity is called encapsulation, which means again, go back to the car concept. Car is an object. The properties, the brake, the tire, the seat, the steering, everything inside the property, right? All the properties inside the object, right? Every property is inside the object called car. And then apply the brake, car will stop. Increase the gas, the car will speed increase. Turn off the ignition, car will stop. So these behavior, right? The operations also inside the car, right? So that is what called encapsulation. The concept, how they will say, keeping the properties and operations on the properties in a single entity, that is nothing but brakes, tires, and applying the brake, car will stop. These two operations and properties has been kept inside a single entity called car, is nothing but an encapsulation. Okay. So in simple case, I'll explain, you don't need to worry about this line. So basically you remember, how can you achieve in interviews, right? People ask you, how can you achieve encapsulation in Java? Simple line, encapsulation can be achieved by private variables and public methods of a class. Make sense? Okay. So that is another concept called encapsulation. Inheritance. What is inheritance? If you look at the meaning of the inheritance itself, you're getting something from the legacy, right? You're getting something from your legacy. So, or else you getting something from the parent, you getting something from super class or something like that. So what simple way is, what is the beauty of inheritance is, you need to remember reusability. Okay, so let's say a simple way, right? I don't know who invented the car, but so when the first model released, when the first model in the world released, right? They designed the car such a way there are four wheels and there is an ignition, there is a brake, there is a gas, and it runs on the gas, and there will be, four people or five people comfortable seating, and it will be closed all the way 360 degrees. Lights will be arranged in the front, and engine will be fitted into the in the front portion of the car, and when you start the engine, ignite, and the car will start. So these are all the design, the basic design has been done in the beginning, right? So even today, even today, even if it is a BMW, it may be Honda car, it may be Audi, anyone who when they start, even Tesla, when they start designing the car, the first thing that comes into mind is what is the basic things that has been that are there already, right? When in the beginning, when they are defining the car, they set certain rules, certain standards, then you can call it as a car, right? So whoever the new innovation happens, but innovation happens only by adopting the initial things that has been defined. So when Tesla is designing, Tesla guy need not to put an effort to understand what is car, because you just need to take the design that has been there for the car. All you need to do is improvise, or else add, improvise, or enhance the existing car definitions, car behavior, and apply Tesla own characteristics around, right? That's what happening, right? Even BMW happens. So even if you look at Tesla and BMW difference, when somebody says Tesla also has a car, but it runs on the what you call battery, and BMW is a car, it still runs on the gas. Both are cars. So both has been adopted certain basic definitions that has been there. So they reused the existing car definitions and then they enhanced around it, right? They haven't completely went away from the car basic designs. They never went away. They never went away designing a car with four wheels. They never went away designing a car with headlights. They never went away with cars with steering, right? These are all the, if you look at car definition, the car definition is still there in the Tesla and BMW. So they reused. So inheritance is nothing but the core. If somebody asks what is inheritance, why Java adapted, simple line is reusability. Okay, which means when you write a new class, right? When you are writing a new class, we know what is the class, right? Yesterday we wrote a couple of classes. When you are writing a new class, and if there is some behavior already there, then you can take that behavior into your class without writing the code again. So code reusability. Okay, so let me read it out. Writing a new class by using the functionality of an existing class, is called as an inheritance. Existing class is known as a base class. You can call it as a base class. You can call it as a super class or parent class. So, and the new class, whatever the new class that you are writing is called subclass or derived class or child class. Okay. This is the concept you used in your day-to-day life every time you wrote a programs in your office when you joined in a company, right? Okay, remember that is the inheritance. What is polymorphism? Polymorphism, we'll go deeper when we're writing programs, but for now remember there are two types of polymorphisms. Polymorphism is just like, you know, which example I can take? Yeah, simple. I mean, I try. I think I'm close to a simple way of explaining, but I'm not sure. I will double check later after the class. But polymorphism is simple way, I can tell you. Okay, you have a TV and you have a remote, right? There is a button called a red button will be there, right? So when the TV is running, when you press the button, what will happen? It turns off. When the TV is not running, when you press the red button, what happens? TV switched on. So what happens? You press the same button, but what happened? The behavior, the output has been different, right? When you first time when you press the red button, the TV has been switched on. When you pressed again, the TV went off. So one operation, that is pressing the button, behaving differently and bringing a different results, right? Behaving differently in different situations. Different situation is nothing but when the TV is running is one situation, TV is not running is another situation. You got my point? See it, right? It's simple. Yeah, I think I got it. Yeah, whatever I am explaining is perfectly fine. Just go with this. Understand this way. So when you press the button, the situation is turned off. So the TV will be switched on. When you are again pressing on, the situation is TV is turned on, so it will be switched off. So single operations behaving differently in different situations. Okay, one operations will have different implementations, right? You can see the different implementations. Same button, different implementation, turning on, turning off, right? So that's it, simple way, polymorphism. But in Java, we have two different polymorphism. You remember just compile time polymorphism, runtime polymorphism. We know these two words. Compile, what is compile, what is runtime, what is running a program, right? We know these two words, but we don't know what is compile time polymorphism, what is not runtime polymorphism. That is something we will get to know when we do some programs. Okay. So abstraction, encapsulation, inheritance, polymorphism. I hope you guys understand. If not, please go back and hear this session. Understand very well these four concepts, because one thing I can tell you, in each and every interview, right? Even the vendor guys, whoever do, even they don't know Java concepts, they have, but in their list of questions, when they start asking you, these are the questions they will ask you. Okay, so in order to get your resume submitted, first you need to know all these definitions: abstraction, encapsulation, inheritance, polymorphism, object. Good? We're good? Nice. Let me mention the concepts that helps me for the next session as well. Next thing. So now let's see how these concepts adapted by Java one by one slowly. But before that, let's understand the differences of object and class. We keep on using object and class, right? What is an object? What is what you call the object? What is class? So we know, we wrote a class. We know it's kind of I mean, you may kind of understand. Class is something. Come on, buddy. Class is nothing but a simple class that you wrote yesterday and day before yesterday, right? That is nothing but a class. So we can easily understand. But what is an object? Where is that object? Are we writing a keyword called object, or what exactly it is, right? It's maybe confusing you. So it's nothing but simple. What is this? This is the blueprint. This is the blueprint. Okay. What is this? It is a blueprint. So class is a logical entity. Class is a logical entity. Logically it is there. So it's a blueprint. It's just a simple blueprint. Like, when you're designing a building, what is that? Are you designing a building with a blueprint, right? That is nothing but this is the blueprint. You go with, so what is an object? Object is an instance of a class. Object is an instance of a class. Nothing but, so when you run this program, a reverse number object has been created, right? So if you want to, you can see, when you have a blueprint of a building, you can construct as many buildings as you want, right? So nothing is, so it's as simple as that. Object is the physical entity. A physical, it has some shape, some value, it has some characteristics, and it's a physical entity. But class is a blueprint. It's just a logical entity. So it may be still confusing. So we are saying object is a physical entity. Where is the physical entity? How it? I can't see it, right? You can't see it, but JVM can see it, right? When you run this program, when you run this class, what happens? An object will be created. That object will be loaded into this JVM. That JVM will be loaded into the RAM. So RAM is the physical part in your program, right? In programming concept, go into the shoes of the program, Java JVM, right? Go into the JVM shoes and see. The JVM is something a RAM provides you certain setup, like, if you have a 10, 12 or 64 GB RAM, then when you run the program, 10 to 20 GB of, let's say 10 to 20 GB of RAM will be occupied by this JVM, right? Bits and bytes it will be occupied, 20 gigabytes. In that, an object will be created and called a reverse number, and it will be stored as long as you're running the program. The moment you shut down the program, the moment you shut down your computer, it will be wiped off from the RAM. So as long as it is there on the RAM, as long as it is there on the object, it is nothing but a physical entity. Okay, so simply remember, the more feel the sense every time when you are doing the difference between object and class is a blueprint, class is a physical entity, object is something called class is a logical entity. Don't get confused. Class is a logical entity, or you call it as a blueprint, but object is a physical entity. Okay, that plays the role. Okay, simple way, like I said, you have a building design. The building design is nothing but a class, and when you start constructing as many buildings as you can by taking the reference of this building design, those buildings are the physical buildings are nothing but an objects. Make sense? I hope you guys understand. Okay. So next is so how do we create an object? That is something we need to discuss. Let me do so we talked about how do we create an object. We need to see. Give me a second. Let me do some program. So simply to explain you guys, let me write a simple class called so before that, right, as before we'll go to the packages as well, but let's start writing some first packages. Okay, Bell Info package is nothing but like folder structure. Simple way of understanding. Let's say you are when you joined in a company, right? There may be, it's not like one or two programs that you're going to write. They're going to be write like hundreds, sometimes thousands of programs will be there. Thousands of Java classes will be there. So if you keep everything inside this slide, this structure, if you keep everything into this structure, there will be 1,000 classes that will be displayed. It's like more clumsy. It's not maintainable. It's not and you can't create jar files separately. There will be some concept. I'll explain you later. So that is the reason. So simple way of understanding for now, package is a structured way of organizing the Java classes. Okay, understand to that extent. So how to create a package? Go to onto the whatever the project that you are working on, new, there is a call package. I will call, so anything, packages, right? 99% of the companies will start with com dot. So company name, this is fixed. Okay, com dot company name, and whatever I call it as I'm teaching batch 4, be batch 4 dot this is the day 4, right? Session 4, or else I can call it as session 4. So this is my package. Whatever I wrote today, I'll put it all the Java classes into this, so that what will happen is so that in case if I come back, I can easily look at what I teach. And even better way is I can do is like refactor, rename session 4 object oriented programming concepts, so that if I by in case if in case Bell Info organization, like TM manager or someone comes and asks me what did you teach on particular day, then I can simply tell them, okay, this is the package that I created on the day when I'm teaching a session for object oriented concepts. On session 4 I explained them object oriented concepts. So in future, if somebody asks how many batches you teach as of today, I can tell by looking at, okay, this is the 4th batch that I'm teaching, right? So if somebody asks like which company you are teaching, by looking at what you call folder name, I'm teaching for Bell Info. Even if I'm teaching for bunch of companies across, then by looking at, okay, this is the Bell Info project, and in that currently I finished session 4 batch 4 session 4, and in that I am discussing with object oriented programming. So this is the structure. So what happens, just is the name, or what happens if you go and look at the project, right? Let me open the project in folder structure so you can easily understand. Nothing is there, like I'm going to the project. Oh, I'm here. Okay, so what I created, com, so Bell Info batch 4 session 4 object oriented concepts. As there is no programs that I created, under session object oriented concepts, then nothing will be. So if I create now explain abstraction and encapsulation, right? Class abstraction encapsulation or else I already mentioned. So let's say I'll mention car. Okay, I'll say it is a car. Okay. So now if I go back here, car.java. So who created .class file? You didn't type java c and blah 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 in your command prompt, right? How come it created? That's the IDE will automatically generate .class file. Okay, makes sense. So next thing is, okay, this is a car, right? We are talking about object oriented concept. So this is when I say this is the blueprint of the car. Nothing is there, right? Inside I haven't explained, I haven't talked about anything about the car, right? I haven't mentioned about anything about the car. So we need to give some properties, right? What and all the properties we can give? Int gear. So if there is more number of gears, you can assign that value. Int number of seats. Boolean is Tesla runs on what battery, right? Is battery engine int number of, for now, okay, let's keep like this. So these are the for car behavior I am giving, for car properties that I am giving, right? These are the car properties I am giving. So in that, let's say I'll call it as void, public void, change gear. Int value. So see, I didn't explain you guys, right? So when you write a class name, what you need to do, always use the capital letter for the class name. And when you're writing a method, all methods should be in first rail, right? When you're writing a method, all methods should be inside class. All variables should be inside class. Everything should be inside class, okay? And when you're writing a method name, this is the variable, right? Method name variable change gear. See, if you look at small letter and capital letter in between. So when you're writing a method name, it always should be start with small letter, and each word should separated with a capital letter, okay? And it takes as many input parameters. These are all called input parameters. That has been, we will call it as input parameters, okay? This is called return type. This is called a return type. So what does it mean? This change gear method takes inputs, okay, as input as int value, int with variable name value, and it does some operation, and it returns something. It can return int again, or it can return void, or it can uh, it can return something double. Anything it can return, okay? This is the return type, okay? So for this method I'm just keeping it as void, okay? So what I will do, I'll assign gear this value, whatever the value that has been provided. Okay, just try to understand. We will do only these concepts programs today. We are not going to do much more than apart from that. Okay. Let's take a number of seats is going to be always for, let's say, because I know, I mean, we can change the number of seats as well. So let's say public void increment seats int some number of seats int some number, some value, right? You can call it as anything. It's a variable, right? So by default car should have 4 seats, so number of seats equal to 4 number of seats plus whatever the number that has been provided as an input. See, we defined these variables outside the method, right? We defined these variables outside the method, but we are trying to access those variables inside the method. Can you guys feel it? We defined these properties, but we're trying to access inside the method. Okay, so now what else we have? Let's display something like, if somebody asks void print car details. Okay, you just need to call them. So what we can display is system dot out dot println, let's say string. For now, string is which will hold the variables, right? It's a class, but we'll go details about the class. But if you want, let me get the battery. String for now considered as a string is like which will hold a which will keep as much big strings, big words as it can. Okay, car name. Okay, okay, so let's write another method to access that. Update car name. Let's provide car name. What they can provide a string, right? String name. So what we can do here, assign whatever the provided name to car name. Okay, now here car details. I'm going to print simply car details. Don't worry, just focus, just keep looking and try to understand as much as you guys. The more you do these programs, the more easily you can understand. Okay, there is no rocket science, trust me. car details, what you called number of seats, number of seats is nothing but you can write number of seats plus some space. You can write like, yeah, you can continue as well. What you call car name, we can pass this guy. Okay, let me do what else you could here you can put car name, what is the variable? Car name, right? This is the car name. We need to copy paste here, and on which gear, on which gear, on gear, yes, gear value, whatever the value is. Okay, so check it out. So let's keep this guy first so that you can get some sense. Yeah, now it makes sense. Okay, so all we did is there is nothing is here, just we just added whatever the data that has been provided. Okay, so this is the car. So you need to do some demo, right? So let's write a program, another class called car demo. Okay, car demo. This is where I want to run the program. So that's the reason I want to go public static void main. So now I wrote this car. I gave the properties. There is concepts overlapping, so don't worry. We'll by end of core Java you can understand each and every concept. You know when we progress. So these are the properties. These are the behaviors that we gave. Okay. So I want to apply car demo. Okay. So car demo. What we can do here, you want to create cars. That this is the car. This is what? This is the blueprint of the car. So you want to create as many cars as you want, right? So let's say I call it as car, Audi car equal to new car. So this is how you create an object. I will explain in detail about what is new keyword and what is this Audi car, what is this kind of thing. This is the reference variable of object called car. What do you call this line? Just this part. What do you call this? What is this? Audi car is a reference variable. Audi car is a reference variable of an object of a class called car. Okay, what is this called? This is the car constructor. Car constructor. Whenever you see class name and then two braces, we call it as two closed braces, then we call it as constructor. This we can call it as constructor, the highlighted one. Okay, this is the keyword that will create an object This is the keyword that triggers to create an object called car. Create an object, a car, by using this blueprint, and then after creating in the memory, it will assign it to this reference variable called Audi car. Okay, then what will happen? You want to give some behavior, right, for this Audi car. Audi car dot change gear let's say I keep it as 3 gears, or else rather than confusing you guys, I just renaming it as max gears. What is change gear? It's confusing, right, little? So max gears. Max gears 3. And what and all the other behavior that I can provide? Audi car dot increment seats. So I want to increment, it's a 5 car seat. Okay, Audi car. So I'm providing all the behavior. Okay, and what is there? Max gear and provide car name, right? This is nothing but car name. I can provide string, can be provided with double quotes. Okay, string always need to, for now remember, need to provide it in double quotes. AUDI car. Okay, what is this guy? Max gears, I guess. Why? Because I changed this name. If you observe, its star is there. What does it mean star is there? I haven't saved this class. If I don't save this, the dot class file is the old one. If I save it, the moment I save it, new dot class file will generate. New dot class file will generate, and new dot class file will be accessed here. See, the moment I save it, the error will be gone. See, the error is gone. Okay, so this is one car I created. This is the physical object that I am creating with the help of blueprint called car. Another object, car Tesla equal to new car Tesla. I'm providing the behavior max gear. Let's give spy. Okay, and then Tesla provide car name. What is that? Tesla. Okay, now I created 2 cars. Now I want to see how the details will be print. Okay, what is the behavior when I ask for Audi car, what it will print? When I ask for Tesla, what it will print? So what I will do, Audi car dot print car details. I'll just I created 2 objects. One object is holding called a reference variable called audit car of type car with max gears as 3 and increment seats as 1 and provide car name as Audi car. This is the properties, the behavior that I provided, right? So Audi car dot printed car details. When I run this program, see what happens. If you look at here, car details, car name is Audi car. number of seats is 5 because default seats is 4 and this guy has been incremented here. And max gears available for Audi car is 3. You get my point? So if I want to get the behavior of Tesla, what I need to do? I need to say Tesla dot print car Tesla car details. When I say this, and I'll see 2 car details printed. Below one is car name is Tesla, number of seats is 4, max gears is 5. You got my point? So if you look at here, did I pass number of seats for Tesla? I haven't. Did I increase the number of seats? I haven't. How come then it showed 4? Because the default behavior of the car is defined as number of seats 4. So that value has been given. You got my point? So that is, see, if you look at here, right? Now feel it, like try to feel the abstraction and encapsulation. This is the car blueprint and these are the properties. This is the behavior that I provided. You can write whatever the behavior you want. You can write at whatever the behavior of the car you want. Okay. Then here I created a car object. This is the class. Audi car is a reference variable of type called car, and it got an object called car object with all the default variables. But when I start giving the behavior, Audi car, max gears, increment seats, provide car name, this is the total behavior that I have been given. So if somebody once I initialize the car, Audi car with these details, if somebody try to access outside, can I get the Audi car and try to see the details? You can get all the details of the Audi car. And go back here. So keeping properties and behavior in a single class, in a single entity called class is nothing but encapsulation. And providing necessary details by hiding the internal details is nothing but abstraction. So here, if you look at, you just asked print details. Okay, and you provided here whatever the increments that you want. You don't know how many car seats by default. The default car seats are 4, and you haven't provided, we don't need to provide any other details to the outside world. So we just need to ask now. So that is nothing but providing the necessary details, and hiding the internal details is nothing but abstraction. Okay, we can see inheritance and polymorphism tomorrow. Okay, tomorrow I'll take around 7:30. I'll send an invite tomorrow morning by checking my timelines. Day after tomorrow I'm not taking class. Tomorrow I'll take, if possible, I'll take an half an hour extra. Yeah, so go back, please read Java documentation, Oracle Java documentation that has been there in the internet that I shared a couple of days back in one of the emails. So go back and read these concepts again, and if possible, try to listen the session again. Understand, try to understand the concepts. Okay, it's really challenging for me to, you know, train you these concepts online, but yeah, we don't have any options. We have to deal with it. Okay, yeah, please be focused and keep practicing. And if somebody not completed the assignment, go back and put some efforts to finish the assignment. That is really good for you guys, trust me. Okay, where is this guy? Please don't miss the class.